Hi, I'm Sarada Padathula from Team Mining Minds, Oklahoma State University. Today, I will be presenting our paper titled Hate Speech Classification of Social Media Posts Using Text Analysis and Machine Learning. Before I begin, I would like to introduce you to my team. Sarada Padathula, myself the business analyst, Venki Konduri, our project manager, Ashish Pamu and Sravani Sigdam, the data scientists. Disclaimer. Some content of this presentation may be perceived as offensive and hateful. It is included with no other intention but to emphasize that use of such language is commonly found on social media platforms and may negatively affect some sections of the society. Hate crimes are on the rise in the United States and other parts of the world. In hate crimes, victims are targeted for who they are. They are threatened, assaulted, or even killed on the basis of race, religion, ethnicity, gender, sexual identity, disability, or other characteristics. This chart from US Department of Justice 2018 hate crime statistics shows that nearly 60% of all hate motivated crimes are motivated by a victim's race, ethnicity, or ancestry. So, how is speech related to hate crimes? Hate motivated speech is considered an offense in many countries around the world. The US, however, protects speech under the First Amendment of its Constitution, but only as long as such speech doesn't interfere with the civil rights of others. In the past decade, the social media usage has increased exponentially. About 45% of the world population are social media users. That is about 3.7 billion people out of a total 7.7 billion world population use different kinds of social media, ranging from Facebook, WhatsApp, Instagram, Twitter, to many others. So, with these numbers, we know that hate has a propensity to spread expansively and rapidly, and even motivate individuals who are inclined towards hate. Now, let us look at some usage statistics of Twitter, which is the platform on which we based our study. Twitter has, as of 2018, Twitter has about 330 million active users per month who spend an average of 3.39 minutes per session. The users of Twitter produce a massive 500 million tweets per day. This contains all kinds of content like news, opinions, thoughts, hashtags, and even hate. Twitter has been the social media platform of choice for many eminent people around the world, ranging from leaders of nations to business leaders to celebrities to sports stars and many others, along with common people. Many a times we have seen that none of these users have been immune to controversy or sometimes even legal troubles for posting something distasteful on Twitter. This is the whole idea behind our analysis. That is, to come up with a model that can classify tweets based on their content, specifically hateful versus normal, and alert the users before they post it on the public platform. Now, here are examples of two tweets that caught the attention of media and people around the world. These tweets, as you can see, are filled with hate and prejudice. These tweets not only caught the attention of people but also cost the tweeters dearly in the form of lost career opportunities, backlash, and embarrassment. Now consider two real tweets by users, say Jane Doe and John Doe. Take a moment to read them. Both these tweets sound like threats, and that is the same reason these tweeters got into trouble with the police, as reported by a Business Insider article. Later investigation only proved John to be an excited Pink fan who was completely unintentional in the meaning of his tweet. Sometimes tweeters are a bit too excited, or make a wrong choice of words, or they might be even in a bad state of mind when composing a tweet. Our model can come to rescue in such cases and give the users a second opinion on the tweet that they are about to post, thereby saving them from costly mistakes, backlash, embarrassment, or even potential legal consequences. Any good model begins with good data. Our model needed tweets labeled into categories like hateful, normal, etc., based on content. While many such datasets are readily available on the internet, the issues with them are: is there a subjective bias in labeling? And how did the annotator label a tweet into a particular category when some tweets potentially could fall into multiple categories? With these ideas in mind, we continued our search for a good dataset and finally found one that addressed these problems. This dataset is the output of a research study named Large-Scale Crowdsourcing and Characterization of Twitter Abusive Behavior. This dataset is the output of a research study that used crowdsourcing for annotation of tweets, with multiple people working on labeling each tweet. They used majority voting on a label to minimize subjective bias, and also used statistical analysis like correlation analysis to consolidate overlapping tweet labels into one appropriate label. Our analysis needed two datasets, one for training the model and one for scoring. Our training dataset is from the research team at iDrama Lab. It had about 80K observations, which are filtered out to keep observations of just hate and normal labeled category. So with that, we had a dataset of 58,000 observations. Our second dataset was from hatebase.org, which had a total of about 25,000 tweets, which were again filtered to just have hate and normal, which are the ones needed for our analysis. And this was our test dataset or the score dataset. As you can see from the legend below, the training dataset had only 8% of hate tweets and 92% of non-hate tweets. Similarly, the scoring dataset had 26% hate tweets and 74% non-hate tweets. The training dataset was severely imbalanced. In order to compensate for this and to override any overfitting problems, we performed stratified undersampling over the dominant class. Now, let's look at a high-level overview of our process. Our analysis began with text pre-processing. This involved two steps, namely text parsing and text filtering. Text parsing breaks text into tokens of words, detects parts of speech, performs stemming, etc. Even the cleaning is done at this phase. The cleaning such as removal of stop words, entities like usernames, phone numbers, and even punctuations. This was done using SAS Enterprise Miner's text parsing node. Once text parsing has been done, text filtering was performed by using SAS Enterprise Miner's text filter node. Text filtering helps to remove terms based on term importance through weighting techniques such as TF-IDF. Simply put, TF-IDF is a statistical measure, which is numeric, about how important a word is to a document in a corpus. So using this numeric, unimportant and insignificant words are removed. Once this step is finished, we move on to the next step, which is called topic mining. This is done using SAS Enterprise Miner's text topic node. This text topic node helps detect text topics automatically. Topics are collections of terms that describe and characterize a main theme or idea. Using a score assigned to each document and term to each topic, the text topic node determines whether the document or term belongs to that topic by checking against a threshold score. So our model generated about 25 text topics related to different categories like hate, normal, and other general categories. Once the text topics are derived, we split or partition our dataset into 70-30 for training and validation. After this has been done, we built models on our data for performing classification of tweets. For this, we used logistic regression, decision tree, and gradient boosting. Once we built the models, we compared them using SAS Enterprise Miner's model comparison node. Now, let's take a look at some of the text topic terms from our model. This figure shows you side-by-side comparison of non-hate versus hate terms, which are part of our text topics. As you can see, terms like country, birthday, goal, glad, beautiful, celebrate, story, and others are non-hate topic terms. Whereas in the hate theme terms, we see hate, bloodbath, disgust, threaten, extremism, sexist, racist, and others. So this gives you a brief idea about our text topics. Now, coming to the model comparison. From the results shown below, you can see that gradient boosting has the highest validation accuracy, and SAS's model comparison node using this validation accuracy determined gradient boosting as the champion model. Accuracy is the measure of the number of correct predictions per total number of predictions. So out of the logistic regression, decision tree, and gradient boosting, we see highest validation accuracy in gradient boosting, whereas the training accuracy is same for decision tree and gradient boosting, slightly more than the logistic regression. Now, coming to how the champion model generalized on the scored data. These charts show the accuracy, sensitivity, and specificity of our model in classifying the validation data and scoring data. We can see that our model sensitivity on the scoring data is 66%. Sensitivity is the true positive rate, whereas specificity is the true negative rate. So we can say that about 66% of hate labels in our model are predicted as hate. Here are some examples of tweets that are model labeled. Just like any other classification model, our model has its share of true positives, true negatives, false positives, and false negatives. From these examples, let me explain how our model labels some of these tweets. The first tweet, as you can see, is clearly a hate, and our model predicted this hate tweet as a hate tweet. Second is a normal tweet, and this normal non-hate tweet has been correctly predicted again. The third tweet is non-hate tweet, but it has been incorrectly predicted by our model. The fourth tweet, as you can see, is a hate tweet, but it is incorrectly predicted as non-hate by our model. Potential applications. Our model can be used in proactively alerting about hateful content. This can benefit the users in carefully drafting their tweet. It can also be used by Twitter to flag hateful content. To put our model into implementation, an application may be built on top of it and provided as a feature to the user. Another feature that can go hand in hand with this feature is a recommender system that recommends replacement words for hateful words. Next is the future scope model enhancement. As a future scope, we want to include additional data in our analysis. This data, such as retweets, comments, and likes, might add some insights and help in better classification of our tweet. We would also like to delve deeper into the meaning of the tweet by doing some sentiment analysis. Finally, we would like to extend our application to other social media platforms and also include more labels for categorizing. This concludes our presentation, and I would like to thank SAS and the Global Forum team very sincerely on behalf of my whole team for giving us this opportunity to participate in the Student Symposium. A big thank you to all of you. If you have any questions regarding our presentation, you may reach us at one of these email IDs listed on this page. Thank you.